In natural language processing, researchers study reflexive metadiscourse, language where a text refers to its own structure, like as noted above. By isolating this specific subset of language, researchers attempt to manipulate the discourse directly to see how it affects passage-level properties. To prove causality, researchers take a source text, alter a target variable, like deleting metadiscourse, and compare that treatment against a neutral sham control. This sham introduces a similar disturbance without manipulating the target. This methodology relies on a specific assumption. If a sham control edit manipulates the exact same token burden, meaning it changes the exact same number of words as your treatment, the causal variable is isolated. Stage 2A of the Minimality program was designed to test this assumption. Rather than observing natural texts, it used deterministic editing rules to forcefully manipulate 2,000 passages. The results of this experiment provide empirical evidence that token-matched controls can fail to produce a valid comparison. Surface-level token equivalence does not ensure that the structural disturbance of an edit is also equivalent. To maintain scientific rigor, the experiment utilized a validity firewall. This was a sequence of zero-tolerance evaluation gates that every text had to pass. The architecture ensured that any failure at an upstream gate would permanently lock out all downstream computations. If the edit damaged the text or the sham failed to match, the experiment stopped. This chart shows the sequence of automated validity gates. Scientific endpoints, labeled B2, were accessible only if the edit and sham passed every machine threshold. In Stage 2A, the process stopped at machine validity. Scientific endpoints were never authorized or computed. This design emphasizes that a manipulation check, proving the algorithm moved the target score, is scientifically incomplete without manipulation validity, which proves the intervention isolated the construct without introducing confounding damage. Phase B1 tested two directions: 2,000 attempts at deterministic insertion of reflexive metadiscourse and 2,000 attempts at deterministic deletion. While the insertion algorithm successfully moved the target density to the required range, it caused widespread collateral damage to the integrity of the passages. On this pass rate chart, the orange bars represent the insertion arm. Semantic similarity passed in only 84.7% of cases, and fluency reached only 79.7%. Both failed the required 95% machine validity threshold. Because of these fidelity failures, the available sample size for the insertion arm dropped significantly. After filtering for machine-eligible triads, only 879 usable passages remained. As shown in the attrition data, 879 passages fell below the pre-registered 1,000 triad floor. Consequently, the precedence rules forced a terminal classification of execution invalid for the entire insertion arm. The data shows that injecting metadiscourse through deterministic templates degrades textual cohesion beyond acceptable limits. For this version of the machinery, deletion was the only direction that preserved machine-detected fluency. The deletion arm initially appeared to be an operational success. The blue bars on the pass rate chart show the algorithm effectively removed reflexive markers while clearing the 95% thresholds for semantic preservation, fluency, and length. However, clearing the fidelity gates for the true edits did not ensure a valid experiment. The deletion arm critically failed the G3 sham validity gate. In the attrition chart, the deletion arm drops to 1,513 machine-eligible triads. 440 attempted triads failed at least one sham validity condition.
This 22% failure rate exceeded the allowed 5% tolerance, resulting in a sham invalid label. The records allow us to rule out the most obvious causes for this failure. The token delta between the true edits and their sham controls matched exactly at 0 for all constructed triads. The secondary check for word type also passed. The broad slot types, the linguistic categories of the words removed, matched exactly between the treatment and the control. These results reveal a conflict in surface-level matching. The researchers aligned the exact number of words and the exact type of words, yet the resulting controls remained non-equivalent. A forensic audit of the data ledger identifies the specific cause of the G3 failure. The distribution shows one category of error far outweighed all others. Out of the successfully constructed deletion triads, 377 shams failed specifically due to a composite disturbance class mismatch. The composite disturbance class represents the structural repair profile required after text is removed. It is primarily determined by punctuation repair and clause reconnection rules. In a true edit, removing a reflexive phrase like "to clarify" often requires 0 surrounding punctuation changes. The adjacent branches of the syntax can snap together seamlessly while remaining grammatical. The sham edit is different. Removing a non-reflexive sequence of the identical length frequently leaves behind broken structures, such as a dangling comma or an orphaned clause. To make the passage readable, the system must forcefully repair this punctuation. This repair alters the text's syntactic profile in a way the true edit did not, creating two passages that are no longer structurally aligned. The automated validity gates flagged this discrepancy as a mismatch in editing disturbance, stopping the experiment before any scientific conclusions could be drawn. Removing superficially identical pieces of text creates structurally unequal damage. Token burden proved to be an insufficient control for the actual burden of the intervention. We can see the value of the firewall by considering what would have happened if the G3 gate were ignored. If the researchers had proceeded to analyze the data, they would have compared structurally mismatched passages. The flawed shams would have been compared against the true edits to measure shifts in compression, frame sensitivity, or recurrence. Any observed changes in those properties would likely have been caused by the collateral damage of the sham's punctuation repair, rather than the removal of reflexive metadiscourse. The validity firewall architecture prevented this by refusing to output a scientific estimate from a contaminated sample. By halting the process, the experiment converted a systemic risk of false positive results into a direct proof of methodological failure. This illustrates the balance transfer phenomenon. Forcing absolute equivalence on a surface metric like word count doesn't remove the bias, it merely squeezes the imbalance into deeper structural or pragmatic metrics. These results align with the theory that linguistic properties are relationally determined. A word is defined by its role in the surrounding discourse, not just its local syntax or length. In this study, a control edit matched the treatment exactly in token burden and slot type, yet failed to match the actual disturbance introduced by the intervention. The findings show that for linguistic interventions, a control can match a treatment in token burden while remaining structurally unequal in its disturbance profile. The Stage 2A results demonstrate that surface-level manipulation checks can be insufficient for causal inference.